Insert greater than, less than, or equal to between each pair of fractions. So for A, we've got 1/2 and 2/4. Let's shade it in the diagram. Yeah, we've got 1/2, and directly beneath it, yeah, we've got 2/4. Do you notice that these two are exactly equal to one another? Now, if we didn't have a diagram to shade it in, we could think we are comparing halves to quarters, which makes it difficult. So, we know that we can write an equivalent fraction for 1/2 as something out of 4. So we times the top and the bottom by 2, and from there we see that 1/2 is equal to 2/4, like we saw here. For B, 1/2 and 3/4, so let's first use the diagram. There's 1/2. Directly beneath it, there's 2/4 and there's 3/4. So we see that 3/4 is bigger. Now, if we had written 1/2 as something over 4, so that we compare quarters to quarters, times the bottom by 2 and the top by 2. Now we know that 2/4 is smaller than 3/4, and that is why we have answered it like such. Let's move on to number 2. Insert greater than, less than, or equal to between the pair of fractions. So for the first one, we have got 1/3, and directly beneath it we have 2/6. So these two we can see are exactly equal. Now 1/3 is something out of 6, we times top and bottom by 2, and there you see in fraction form, that is why the two are equal. 2/6 is equal to 2/6. For B, let's shade 1/3 in the thirds block, and directly beneath it we have 1, 2, 3, 4, 5, 6. So we see that 5/6 is much bigger than 1/3, and that is because 1/3 is only equal to 2/6. If we compare 6 to 6, it's nice and easy. For C, now before I shade it in, let's write this as something out of 6, so we can compare 6 to 6, times the bottom by 2, times the top by 2, 4/6 and 5/6. 5/6 is bigger. Now let's shade to see if let's confirm the answer. There we've got 2/3 or 4/6, and beneath it we've got 5/6, and this is why 5/6 is bigger. It's just a bit bigger there. Let's move on to number 3. Again, insert greater than, less than, or equal to between each. So we've got 1/4 at the top there compared to 2/8. We can see that those two are exactly equal, and times the bottom by 2, the top by 2. So we know that 2/8 is equal to 1/4, and that's why these two are equal. For B, now we've got 1/4, let's write it as something out of 8, times top and bottom by 2 is equal to 2/8. So 2/8 or 1/4 is less than 3/8, and if we shade it there, we've got the 1/4 or 2/8, and there we've got 3/4. For C, times bottom by 2 times top by 2. So 3/4, which is equal to 6/8, is greater than 5/8. Let's shade it. Yeah, we have our 3/4. Yeah, we have 2, 4, 5/8. That's why the 3/4 or 6/8 is bigger than 5/8. Number 4, now we have to do without a diagram. So 1/3 and 2/9. We have different fractions. There are different numbers at the bottom here. So we know that we can write 3 as something over 9 by timesing top and bottom, because 3 fits exactly into 9. Times by 3, times by 3. And 3/9 and 2/9 we can compare. 3/9 is bigger. That means that 1/3 is the greater fraction. For B, we've got quarters and 12ths. Now we can write this fraction as something over 12, times by 3, times by 3, and 9/12 or 3/4 is greater than 7/12. 8/15 and 3/15. Now we're going to rewrite this one here as something over 15, the one with the smaller denominator. times by 3 times by 3, and 9/15 or 3/5 is greater than 8/15.